My name is Paul Goldbart, and on behalf of the Department of Physics and the Institute for Kinetic Matter Theory, it's my pleasure to welcome you to Lewis Lab. We're gathered, as you know, to celebrate the many rich and important contributions to science made, like many of them here in Urbana, by our friend and our distinguished colleague, David Pines. Just a month or so ago in Japan at the 9th International Conference on Materials and Mechanisms of Superconductivity, David received the 2009 John Bardeen Prize for these contributions, especially his groundbreaking work on superconductivity in its many beautiful and varied forms. It's particularly fitting and indeed moving that David should be the recipient of an award designed to commemorate the incomparable John Bardeen, in view of David and John's lifelong friendship and shared scientific passions. It's fitting, too, that we should be celebrating here in Urbana, the home of John and David's friendship and the home of the Urbana style of scientific research with its close interplay between theory and experiment, a style that John and David defined and exemplified, a style that is indeed virtually synonymous with them. In a moment, we shall be hearing from our colleagues Dale Van Harlingen, Tony Leggett, the 1994 recipient of the Bardeen Prize, and Charlie Slifter, each of whom shares a deep scientific and personal connection with David. But before we do, I'd like to have a reprise of the remarks delivered by another colleague of ours, Philip Phillips, who was chair of the 2009 Bardeen Prize Selection Committee, had the honor and pleasure of presenting the prize to David in Tokyo. Now, ideally, you'd be hearing from Philip at this point, but to his great regret and mine, he had to be out of town today. So, my voice, but Philip's words. On behalf of the Bardeen Prize Selection Committee, Doug Scalapino, Yoichi Andu, Grisha Volovic, Mac Beasley, and Morris Rice, I, Philip, would like to announce the 2009 recipient of the Bardeen Prize. The winner this year, David Pines, is one of the most recognized members of our community. He was chosen from a rather select group of prominent nominees. The overwhelming consensus of the committee was that David's work on the electron-phonon interaction that underlies the BCS theory of superconductivity and his application of the BCS paradigm to nuclei and neutron stars stood out as exemplary and best representative of the spirit of the award, which is to honor theoretical work in superconductivity that leads to verifiable experimental predictions. I'd now like to invite Dale Van Harlingen, head of physics, to say a few words.
Okay, I'll try to be brief, which is not usually the case for me. But so I think all of us know David Skill as a theorist, and of course we're very proud of that history. We invite him back whenever he wants to come. We believe he's still a part of our department very strongly. But I want to talk today about David's role as an experimentalist, not as a theorist. David has never lost sight of the fact that despite the beautiful theory he does, the answer will always come from experiment. And he's always been a strong proponent in that, his words are, the most three important things in high temperature superconductivity are samples, samples, and samples. I think I got that right. So he always recognizes the important role of experiment. He's never lost sight of the fact that you have to eventually test things. And in fact, one of the criteria of the Bardeen Prize, as Paul mentioned, is that it has to go to theoretical work that is experimentally testable. And some of the theorists out here should keep that in mind, I think. So in the early days of high TC, I don't think David was the first to propose. So I want to talk now about something that's very personal in my own research. So I don't think David was the first to propose that the Coop rates were D-wave, but he was the most persistent. And eventually everyone else gave up on that idea, except for David. And there was a time when I think you may have been the only one. But we trusted David, and so it inspired many experimentalists like myself to really go out and look for this. And so it was David who persisted that it was D-wave, and we should take that seriously. It was David who steered Tony Leggett, who came to him about his idea for an experiment, to Don Ginsberg and I eventually. It was David that when we got the first data that seemed to indicate that the pairing symmetry was S-wave, it was David we were afraid to go and tell. And it was, when we did in fact show that it was D-wave, I think David was the most happy, but probably the least surprised, because he knew that it had to be D-wave. And so it's for those kind of dedicated things that I will always remember David. He really inspired our experiments and many other people in the realm of experimental physics. And I think it was a really important part of that. And I'll always really remember him for that and for something that was very important, I think, to this department. I watch him now at conferences. I see him. Somebody said, have you seen David lately? Well, I never see him here, but I see him all over the world. And I had the pleasure of being at the Tokyo meeting. It was really magnificent. And I can tell you that everyone who heard that he had won this prize were just enormously appreciative and thought it was well-deserved, and in fact wondered why it took so long. And so now David is actually fronting a lot of other important things, and never again losing sight of experiment as things go on. So David, I want to just honor you, David Pines, the experimentalist.
Thank you very much indeed, Dale.
It's a very happy occasion. I'm proud to say that I've known David for 45 years, and it actually seems longer than that, because when I was a graduate student in Oxford in the early 60s, the one book which almost became our Bible was David's book on the collection of papers, and most importantly his introduction on the many-body problem. And that is probably the most dog-eared book that I think that I still have on my bookshelf. It's really very, very valuable to us. His name in the field was just towering, and so when eventually I graduated and had to look for a postdoc, I went to my supervisor, the late Dr. Ha, and said, where should I apply to? And he said without hesitation, you apply to David Pines. So you go to try to go to Illinois. And so I did, and David, much to my surprise, did actually accept me as a postdoc, and I spent a very, very happy and fruitful year here in 1964 to 5. What I think I learned a tremendous amount from David. I learned some technical things, certainly, but I think what I valued most was that I learned a certain style of doing physics. There was a huge temptation in those days, I think it still is to some extent, for theorists at the postgraduate or postdoctoral level to bury themselves in the most complex possible abstract formalism, and it looked very impressive, but somehow it never seemed to make much contact with experiment. Now, David taught me a quite different attitude. You should actually go out and see what predictions you can make for experiment, and then go and see whether they've been tested, or if not, go and try and persuade some experimentalists to test them. And I think that's really been the most important factor in my own career ever since. When I got the offer of a job from the chair I now hold from the University of Illinois in '82, well, there are a number of factors which weighed in my mind as to whether I should come here or not. One of the most important was the prospect of being David's colleague and being able to exchange ideas with him. And needless to say, that's what we did for many years following our arrival. So I'm also very grateful to David for his role in encouraging me to come here. David's role in the community generally, I think, can't possibly be overestimated. He's probably been co-founder of more institutes, I think, than most of us have ever been members of. Editor of reviews of modern physics, editors of book series, you name it. There's just no area within many-body physics which doesn't bear the imprint of David's influence. So I think it's really very appropriate indeed that he's been awarded the Bardeen Prize, and I would like to congratulate most wholeheartedly. Thank you.